Good morning students. In this class we will be doing class 10 first chapter real numbers. In the previous class I have completed first exercise. So that first exercise is application of Euclid's division lemma. Now in this exercise we will be doing fundamental theorem of arithmetic. This is one more application of real numbers. One more application of real. First application of real number is Euclid's division lemma and the second one is fundamental theorem of arithmetic. So I will be doing the next exercise, exercise 1.2 in this class. Okay, so that is based on this fundamental theorem of arithmetic. Okay, so every composite number can be expressed as a product of primes and this factorization is unique apart from the order in which the prime factors occur. The meaning for this is when you take any number and find the prime factors of that. When you find the prime factors of that, 2, 70, again 2, 35, 5, 7. So these are all the prime factors you will see. Okay, so every composite number, so 140 is a composite number. So every composite number can be expressed as a product of primes. So this 140 can be expressed as the product of primes. That is, all these are prime numbers. So you can express this 140 as the product of primes and this factorization. So if you are finding the factors of this factorization is unique apart from the order in which the prime factors occur. So in any order the prime factors may occur. Either you can start with 5 also, you can start with 7 also. So it will be unique. So this is the fundamental theorem of arithmetic. So we will be doing sums based on this theorem now. That is exercise 1.2. 1.2. So this is based on the fundamental theorem of arithmetic. First sum is finding the prime factors of 140. I have given you an example. So the remaining sums you can do by yourself. These finding prime factorization method, we are doing it from class 6 or 7. So you can able to do the remaining sums by yourself. Second sum is find LCM and HCF of 26 and 91 and verify that LCM into HCF is equal to product of two numbers. So this means this is also a result, verified result. That is, when you find the product of LCM and HCF of any two numbers, that will be equal to the product of that numbers. So that verification you are asked to do. So before doing that verification, you should know HCF, you should know the HCF and LCM of that number. So 26. So 26 is 2 times. So 2 1 times, 3 times. Then 91. 91 also will go in 13 table. 13 into 7. So that's all. These are the prime factors. So 26 you can write it as 2 into 13 and 91 you can write it as 7 into 13. So HCF of this is, HCF is 13 and LCM is 13 into 2 into 7. So 13 into 2 is 26, 26 into 7 is 14, 182. So this is the LCM. So LCM into HCF is equal to product of two numbers. So you are asked to verify that. So what is the LCM? LCM is 30. So HCF into LCM is equal to product of two numbers. So HCF is 30 into LCM is 182 is equal to product of two numbers. So what is the product of numbers? Given two numbers 26 and 91. So 182 into 30. 24, 2, 54, 3 2s are 6, 24, 2 and then 182. So when you simplify, when you find the product of this, you will be getting 2366. So 2366. Then 26 and 91. 26 and 91. So this is 26, 54, 5, 18, 23. So 2366. So when you find the product of this, you will be getting this. This only you are asked to verify. So only one sum I am doing. Do the remaining sum. The sum. Okay. Third sum is finding prime factorization only. You can do that. Fourth sum is given that HCF of 306 and 657 is 9. Find LCM of 306 and 657. We know the result that LCM into HCF is equal to product of two numbers. So we will apply whatever is given in the question, we will apply it in this formula and we will find the LCM. Okay, so HCF of two numbers, LCM only you are asked to find. HCF of two numbers is given as 9 is equal to product of two numbers. So what are the two numbers? 306 and 657. So when we simplify this, we will get LCM. So LCM is equal to 306 into 657 divided by 9. So 9 and 306 will go. 9 1 times, 9 3s are 27, 9 4s are 36. So when you multiply 657 and 34, you will get 2, 26, 2, 17, 19. So 8, 3, 3, 2, 2. So double 2, double 3, 8. So this is the LCM of the given two numbers. That only you are asked to find. Okay. Sixth sum is check whether 6 power n can end with the digit 0 for any natural number n. So n is the natural number given. So if you take 6 power 1, it is 6. So 6 power 2, that is 36. Then 6 power 3 is 216. Like that it will go. So all are natural numbers. So 6 power n can end with the digit 0. So if you are finding any power, if you are writing any power, any natural number as the power of 6, you are asked to check whether it is ending with the digit 0. That is the thing you are asked to prove. So for proving that, we will use fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? All the prime factors, prime factors will be unique. That is the fundamental theorem of arithmetic. We will use that theorem to prove this one. So if you take 6 power n, what are the factors of 6? When you find the factors of 6, you know that it is 2 and 3. 2 and 3 are only the prime factors for that. If any number has 5 as the, if any number is having 5 as the prime factor, then only it will be ending with the digit 0. Okay, for example, 5. If you have 5 as the factors for that. For example, if you take 10, what are the factors for that? 2 into 5. So that number will ends with 0. This is the condition for that. Okay, so if 6 power n ends with 0, then it must have 5 as a factor. If it has 5 as a factor, then 6 power n, we can say that 6 power n can ends with 0. Or if it has the factors of 2 and 5. If you take 15, it won't end. Even though 5 is having you are having 5 as a factor, it is not ending with 0. But if you take some other number, if you take, that is 20 you take 20. What are the factors for that? 2, 10, 2, 5. So this will end in 0. So if you have 2 and 5 as the factor, 2 and 5 as the factor, then only it will end in 0. Any number you take, if you have that as the factors, it can be powers of that. 2 power 2 into 5 power 5. Like that also you can have. But the prime factors should have only that 2 and 5. Then that number will ends with 0. Here if you take 6 power n, what are the factors for that? 2 and 3. That is 2 into 3 whole power n. That is equal to 2 power n into 3 power n. That is 2 and 3 are the only factors. That is, as I told you, using the fundamental theorem of arithmetic. prime factorization of each number is unique. So 5 and 2. 2 and 5 is not the factor of 6 power n. So this we checked that the 6 power n cannot end with 0. Okay. Sixth sum. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. We know two types of numbers. One are prime and the other one is composite numbers. Prime numbers have the number 1 and itself or the factors. They are the factors. If you take 5, the factors for that 5 is 1 and 5, the number itself. But composite numbers have many factors. So it has the 1, the number itself, and many other factors it has for composite numbers. So you are asked to check that whether these two numbers, explain why they are composite numbers. You are asked to explain why they are composite numbers. So if we have more than 2 factors, so we have to show that this number has more than 2 factors. Okay. So if I take 7 into 11 into 13 plus 13. 7 into 11 into 13 plus 13. In both these terms, 13 I can take it common. Balance will be 7 into 11 into 1. 13 I have taken out plus 1. Okay. So here 13 into 7 into 11 is 77 plus 1. So 13 into 77 plus 1, 78. So I got 2 factors for this number. Okay, so whatever number is given, for that I got 2 factors. So they are composite numbers. Then next sum is 7 into 6, 5, 4, 3, 2, 1 plus 5. So in this 5 is common. Number 5 is common. That I am taking it out. So 7, 6. Since 5 I have taken out, balance I will write it. 3 into 2 plus 1. Since 5 I have taken, balance is 1. So here, when I multiply all these things, I will be getting 1008. 1008. When I multiply all these things, 7 into 6 into 4 into 3 into 2, when I multiply, that is 7 6 are 42. Okay, 7 6 are 42. 4 3s are 12. 12 2s are 24. So when I multiply this, 6 4 10, 7 6 5 5 I have taken out, 4 3 2. So 6 7s are 42. 4 3s are 12. 12 2s are 24. So 4 2s are 8. 4 4s are 16. 2 2s are 4. 4 2s are 8. So 6 plus 4, 10, 1008. So 1008 I am getting plus 1. So this is 5 into 1008 plus 1 is 1009. So I am getting 2 factors other than the given number. I am getting 2 factors. So this is also composite numbers. So the next sum is a word problem. When you go through that, it will be an HCF or LCM sum only that you can do by yourself. Now, this is exercise 1.2. I have completed exercise 1.2. In each model, one sum I have completed. Remaining sums you do by yourself. And the next class I will be doing exercise 1.2. So, do practice will. Okay, if you have any doubt, message me in the comment box. Okay, thank you.